In this video, I'm going to show you how to make the cluster density 4-color image for your lab report. This is a great tool for troubleshooting a sequencing run. We want to look at the actual images, the photographs that the Illumina sequencer took during each sequencing cycle to get an idea if there was too much DNA in the flow cell, just the right amount of DNA in the flow cell, or there could have been more DNA in the flow cell and we actually could have gotten more data from the run. You can analyze this figure in your lab by comparing it to the Illumina documentation on optimal clustering. In order to get each of these pictures, you're going to click on the Files tab, Thumbnail Images, Lane 1, C1.1, and you'll see that the first couple cycles of thumbnail images show up on the website. If you want to get more thumbnail images, you can actually get those from the sequencing computer. We can click on each of these to download them. Once you've downloaded all 4 images, which I have already done, you're going to open up ImageJ in a new window. And we're using the JavaScript web-based version of ImageJ, so you don't have to install anything on your computer. I'm going to start with the T channel. So I'm going to open up the T image. And I'm going to use the colors that are on the Illumina graphs. So if I go to base space, I can see that each of the graphs, like for example, percent base per cycle, colors T black, G blue, C green, and A red. So those are the colors that I'm going to use to create this 4-color image. In order to do that, I want to start out by making every image black and white, get rid of those yellow lines, use a lookup table to apply a false color. Since T is black on the graphs, I'm just going to leave it black and white, convert the image back to RGB color, and then open up the next image. So I'm going to open up the G image next. I'm going to convert it to 8-bit to get rid of those yellow lines, use a blue lookup table, since on all of the base space graphs, G is blue. And then I'm going to use Image Calculator under the Process menu to add the 2 images together. Before I do that, I have to make sure to change the G back to a color image. So I change it to 8-bit, use a blue lookup table, and then change it back to color. Now I can add the 2 images together. I'm going to add the T with the G, say OK. And now I have 2 of the colors for the sequencing run in one image. I'm going to close both of the G and the T files. And now I'm going to open up the next channel. File, open, select local file, get the C image, change it to 8-bit to get rid of the yellow lines, go to image lookup table so that I can change false color the image green, go to image type RGB color so that I can combine it with the other images, and process Image Calculator. I'm going to take the image of T and G combined and combine it with C. All right, so now we have 3 colors combined, 3 images. We can close out our pictures that we're not going to use, and then open up the last base, open up the A image, convert it to 8-bit, use a lookup table to make it red, use type to make it a color image so that we can add it to our combined image with the 3 colors. Now we've created a 4-color image. This is what you'll put in your lab report as the figure to describe cluster density. And you can get an idea of how evenly distributed the bases were. So there's, approximately an even number of A G, C, and T. You can see how they're evenly distributed on the flow cells. So we don't have regions that are all A, all C, all T. You can see the difference between the bottom right portion of the flow cell, where we really have an optimal cluster density and there's some black background, versus the top right, which is more densely clustered. So this is what you'll include in your lab report, and this is what you'll write about and compare it to Illumina's documentation on overclustering. You can get this by just Googling Illumina optimal clustering, and you can get some pictures of what the cluster density should look like for a sequencing run.